Good morning, one and all. Myself, Aruna, Assistant Professor in the Department of Allied Science, RLJIT. So, today I am going to explain the derivation angle between radius vector and tangent. In the examination, they will ask the question like prove that tan phi equals r into d theta by dr or cot phi equals 1 by r into dr by d theta. So, before going to this derivation, let me explain the basic concepts. So that is what is the Cartesian coordinate. So Cartesian coordinates are represented by x comma y. And if you want to write in the plane means, let me take one xy plane. This is x axis, this is y axis. If I take the point like P point, the coordinates like x and y, and we can join this, and this is nothing but origin, and this distance is nothing but y, and this distance is nothing but x. Similarly, polar coordinates it is represented by r comma theta. I am taking like p of r comma theta. If you want to represent this one in the plane means, so this one we will call in polar coordinate as pole, this is O, and this we will call like initial line. And if you take the point p of r comma theta means, from pole to this point if you join the thing means, the distance is, this is nothing but r. This is we will call like radius vector, okay, and it makes one angle, and I am calling that angle as theta. This is an angle between the radius vector and the initial line, okay. Next, what is the relationship between Cartesian coordinate and the polar coordinate, okay. So for this we will merge that diagram. This is x, this is y, this point may be xy or maybe r comma theta. So as we know that this distance is y and this is x, this is origin according to Cartesian coordinate, or pole according to the polar coordinate, and this is distance r, radius vector, this is angle theta. So now in this right angle triangle, if you take right angle triangle, that is PO, you call this as some m, POM, angle POM equals to theta. If you define sine theta, that is opposite by hypotenuse. So what is here opposite? The angle opposite distance is, this is y, and the hypotenuse is, that is radius vector r. Therefore, we are getting y equals r sine theta. And similarly, if you define your cos theta, we know that cos theta is equal to adjacent by hypotenuse. So adjacent, what is adjacent side in the figure means? We are getting like x, and the hypotenuse, it is r only, and if you simplify, you are getting x equals r cos theta. So what is this x equals r cos theta and y equals r sin theta means? This is a relationship between Cartesian coordinate to polar coordinate. So we are going to use this one in our derivation. So now we will come back to the derivation. So for to derive this, I will take one curve. This curve is r equals f of theta, okay, and I will take one plane now. So from this plane, from origin to this, you draw one line, and this point I am calling like and also you draw one this point I am calling like p of r comma theta or p of x comma y, and this makes an angle theta. As we know that this distance is r, this is your pole. So from this point P we will write one tangent line, see like this tangent line, and this tangent line is making an angle psi, and here we got this one, no, this angle is phi and this is phi, they are same. So now we will write some 2-3 lines about the figure. So you consider like this: let P of r comma theta be any point on the curve r equals f of theta, and it is making an angle theta with radius vector, and this is your initial line. Okay, so therefore the angle you can call like PO, you call this point as some L, okay, some L. The angle POL is equal to theta. Theta is nothing but the angle between the radius vector and the initial line, and OP equal to the distance we are calling like R. This is nothing but the radius vector, and let's draw the line PL. Let's draw the tangent line PL at the point P. It extends the angle psi. It extends the angle psi with the positive x direction. So this is what the positive x direction you call like, this is x axis and this is y axis. So in the positive x axis we have extended that tangent line, and we are getting the angle as psi. So now from the triangle property, as we know that the exterior angle is equal to sum of the interior angle. So this is what our exterior angle, that is outside angle, and the interior angle is nothing but phi and theta. So according to the triangle property, so we having psi equals phi plus theta. Exterior angle is equal to sum of the interior angles. So now we will take tan on both the side. Tan psi is equal to tan of phi plus theta. So it is looking like tan of A plus B. So what is tan of A plus B formula? Is nothing but tan A plus tan B by 1 minus tan A into tan B. If you apply that formula, tan phi plus tan theta, that is tan A plus tan B by 1 minus tan A into tan B. So here our A and B are phi plus theta, phi and theta. So now we will call this equation as 1. Okay. Next we will move on to what is the slope of the tangent. So slope of the tangent, as we know that it is denoted by tan psi is equal to slope of the tangent dy by dx. So now before going to this, we know that x equals r cos theta and y equals r sin theta. So where we know that, here already I shown for you. So x and y are the functions of theta. See, x and y are functions of theta, and here we are having the curve r equals f of theta. So that what we can take x equals r cos theta and y equals r sin theta. Because x is a function of theta and y is a function of theta, we can rewrite this one as the above slope of the tangent. We can rewrite as, I am introducing y is also a function of theta, our x is also a function of theta. So now we will substitute in the place of y as r sin theta, in the place of x as r cos theta. Then what we will get means, see, tan psi equals dy. What is y? You can check the thing here. Y is nothing but r sin theta by d theta. Similarly, x is nothing but r cos theta by d theta. So now we will differentiate this one with respect to theta. R and theta, both of them are variable and it is a product. So we will apply the product rule to differentiate this. So R into differentiation of sin theta is cos theta plus sin theta into differentiation of R is dr by d theta. Similarly, we will apply the product rule for our denominator also, because here also is a product of two terms. So R into differentiation of cos theta is minus sin theta plus cos theta into differentiation of R is dr by d theta. So now I am calling this as R cos theta. So this dr by d theta I am calling like R dash into sin theta. Similarly, in the denominator also R into sin theta. This dr d theta I am calling like R dash cos theta. If you want, you give the reason. Dr by d theta we are writing as R dash. So now both divide both numerator and denominator by the term R dash cos theta. See, this term I am concentrating. This term I am dividing for each and every term for the above equation. Therefore, tan psi equals, so R cos theta, you are dividing with R dash cos theta. For the second term, R dash sin theta by R dash cos theta whole divided by minus R sin theta by R dash cos theta plus R dash cos theta by R dash cos theta. So now if you simplify, you can check the thing here. Cos theta get cancels. You are rest with R by R dash. In the second term, R dash get cancelled. Sin theta by cos theta is nothing but tan theta. And the denominator you can see here, this is minus R by R dash. Sin theta by cos theta is nothing but tan theta plus, here you can see your R dash cos theta cancel with the R dash cos theta and we rest with 1. So you rewrite, if you rewrite R by R dash plus tan theta by 1 minus, for the positive term I am giving the first preference, 1 minus R by R dash tan theta. So what we will get finally, therefore tan psi equals, what is our equation? It is R by R dash plus tan theta by 1 minus R by R dash tan theta. So you call this as equation 2, and already our equation 1 is, we know that tan psi equals tan phi plus tan theta by 1 minus tan phi tan theta. See, check the thing. Which is our equation 1. So this one I taken. Equation 1 is tan psi equals tan phi plus tan theta by 1 minus tan phi tan theta. So I taken both the equation. So now you comparing the equations 1 and 2. You can observe here, see here tan psi, both our LHS was same. And if you check the thing of RHS, see here tan theta is there, here also tan theta is there, and here tan theta is there, and here also tan theta is there, and here 1 is there, here also 1 is there. And if you observe the difference, you are getting tan phi is equal to R by R dash. But we know that R dash, what is R dash? Here I have shown. See what is R dash? R dash is nothing but dr by d theta. So R dash can be written as dr by d theta. If you simplify this, you are getting like R into d theta by dr. So therefore, your tan phi is nothing but R into d theta by dr. So this is what the angle between the radius vector and tangent. because in the figure you can see the thing here. See, this is what the angle, this is what the angle, this is tan psi. So we got tan phi. So this is the angle between the radius vector, this is your tangent line. See, this is tangent line, this is radius vector. So this line is radius vector, this line is tangent line, this is the angle phi. So we have to find out this only. So finally we got that angle as tan phi equals r into d theta by dr. Sometimes they will ask this one to prove in terms of cot phi, then just you take the reciprocal of this. So if you take reciprocal, you will get what is 1 by tan phi. Just you take the reciprocal of each and every term. So it is reciprocal means this term will interchange. This is dr d theta. So as we know that 1 by tan phi is nothing but cot phi. So 1 by r into dr by d theta. So this is in terms of cot phi, this is in terms of tan phi. So this is what the derivation of angle between radius vector and tangent. So in the next class we will discuss the next derivation. Thank you.